little cherubs. How are you all doing?
I'm kind of like tired.
Yeah? How was your
Yeah.
Thanksgiving?
It
Can
was
we not do anything?
short.
No,
Yeah.
so I let you have the day off the day before Thanksgiving, young lady.
Oh. Oh.
We're gonna learn some new math today.
What are we learning?
Transformation!
Is this gonna be on the test?
Yes.
Oh my
Yeah.
god.
You need to know this.
I'm nervous.
It is a New Jersey core standard.
I'm bad at math.
No, you're not. You're a female. Females rock at math. Female power!
Okay.
Alright, ready?
Mm-hmm.
So today we're going to learn about transformations because the core standard tells you that you need to learn about transformations. It's part of geometry, obviously, because you signed up for 10th grade geometry. And yeah, so let's do it. First, we're going to learn about translations. So a translation is a transformation that slides a figure across a plane or through space. And all points of, yes, dear.
What's a plane?
Good points. Need a marker. Okay. So, one of you fine, lovely people want to bring that camera over that you're not supposed to know about, that I know about?
What? You're filming us?
So, plane is simply basically it has four coordinates. Four quadrants, and you have two different axes, and you have points on a plane. So there are different points, which we won't get into because that's not the point of the lesson, all right? But you number them, you have different points, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, and then, so the shapes that we're going to learn about are going to be on this lovely plane. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so all points of a figure move the same distance and the same direction. And a translation is specified by direction and distance. So basically what happens is you have a triangle right here. It's going to move the same distance and the same direction. So we'll just move, it just translates. So it just moves across. Say you want it to move across 3 units to the left. So you would count your numbers on the plane. 1, 2, 3, and you're at the west. Yay! Translation. Do you get it?
Yeah, I think so.
Yeah? You guys are gonna do problems at the end, okay?
Okay.
Next. How about you guys read that for me?
Okay. Both of them?
Yep, everything on that
I'll read the
slide.
second bullet.
Okay.
Okay.
A transformation that slides a figure across a plane or through space.
All points of a figure move the same distance in the same direction. It is specified by direction and distance.
Good. I'm proud of you. Rotation! So rotation is basically another transformation. We're gonna need you again. But we don't necessarily need the plane for this one because you're just gonna, the figure just turns. A transformation that turns a figure around a point or a line. The point a figure turns around is called the center of rotation, and it can be on or outside the shape. So, over here, Miss Camera Lady.
Oh, shoot.
Doo-doo-doo.
I hope that's been recording.
So, say I have a triangle. And it wants to there's going to be a center of rotation. So what it's going to rotate around. We're going to make it on top of the triangle, right here. Give me a degree.
90.
90. So it's just going to spin 90 degrees. That's 90, right? pretty sure that's, okay, yeah. So that's 90. And so that's a rotation. All right, you guys want to read that so I know you understand? Or, I mean, I'm going to see if you understand later, but I need you to read it so that you get it in that brain of yours.
Rotation, a transformation that turns a figure around a point or a line.
The point a figure turns around is called the center of rotation. It can be on or outside the shape.
Good job.
Thanks.
Reflection. Reflection's easy too. It's a transformation that flips a figure across a line. Yes.
It's kind of like a mirror when you look back and
Perfect!
yeah.
So proud of you. All right. So a reflection. Who wants to read that definition for me?
A transformation that flips a figure across a line.
Good. Camera lady, get back up here. So we're gonna get back to our lovely plane, and what we want to do is, so we're gonna have a triangle again. You can pick any line. I mean, like, the problems are gonna tell you what you want to flip across. What are you doing on your phone, Marissa?
Sorry, I just posted an Insta and like I'm getting a lot of likes.
An Insta of what? You're in a classroom.
It was from a few days ago.
All right. Well, please put your phone away, dear.
I'm sorry.
Thank you. You're learning something very important for your national test, and I need you to pay attention. It's a core standard. All right. So we're gonna flip across a line because that is what a reflection does. So we're gonna flip it negatively, and it goes like that. It turns out upside down when you reflect it, yes.
What if it rotates to the left?
If
I mean reflects.
reflects to the left, it'll be the same.
But like as you said negatively when it like went down, so like what is that since it goes to the left?
Oh, I guess you could say negatively on the x-axis
Okay, I was just wondering.
and the y-axis.
Okay.
Okay, cool. And good job. Good question, Marissa.
Thank you.
Now, we're going to go to, I'm going to wait for our lovely student to sit.
Okay.
Dilation. Now, dilation is probably the easiest. It changes the size of the shape without changing the shape. So,
How does that happen?
I'm confused.
it's magic. Magic. So it just grows, basically. So say you have a star. I'm sorry, I'm a bad star drawer. Camera lady. Patrick. Yeah, you could say Patrick star. Everyone loves a good SpongeBob reference. So that's the star. Can you even see the star? Yeah, you can. Okay. And so dilation is simply, oh, look. The star is smaller. Or you can make it bigger and start with a small star and have a bigger star. Get it? Do you understand me, Marissa?
I really like this one.
Okay, well, I'm sorry, but you gotta do it. I promise, I'll give you baked goods after class, all right? I made sure to bake some brownies for all my good students.
Thanks.
Okay, ladies. So now we're gonna practice. Yay! So, can someone tell me why this is a translation?
Because it just moves from one point on the axis to another point further down the axis.
I am so proud of you.
It's moving to infinity.
Okay, and beyond. I cannot participate in your nonsense. Dilation. Why is it the dilation? Marissa, why don't you have a turn? I think you can do it.
It like changes like size,
Yeah.
but doesn't change shape.
Correct. Good job. Rotation. Why is that a rotation? Yeah.
I used to watch The Big Comfy Couch a lot, and like she would turn around and rotate like a clock,
Uh-huh.
so like it rotates.
Good. Yes. If
Like
that
a
helps.
clock.
If that helps you remember.
It
Good
does.
clock. Perfect. And then reflection.
Reflection, just the same figure reflected on the other side of the axis.
Yeah, I'm so proud of you ladies. So now what I'm going to do for some fun is we're going to put some problems on the board. We're going to do them. Okay. So you guys, as I have my back to you, because everyone knows you're not supposed to have your back to your students, you're supposed to make eye contact. I'm going to have my back from you for a couple minutes while I put these problems on the board. Are you going to behave?
I'll try.
Okay.
Oh my god. Honestly, I was like, did you see my Instagram page? Oh my god. What a time.
All those likes.
I know, right? Like, I didn't get as many as I wanted, but like, I just can't. Okay. So crazy.
Be here. Problem.
I don't either. Go to sleep. Just like, don't sleep anymore.
Just want to bring
Oh
that.
my god. What a mess. A mess.
What time is it?
Are you
That's
ladies
over.
okay over there? Remember, you're getting baked goods after this.
Sick of this class. I hate math.
You're good at math, Marissa.
Not really. Oh, I'm so tired. I have practice later.
What am I missing?
It's just
Rotation.
like so hard, like
What-
balancing everything.
What sport?
I run track.
Ooh, fancy. Okay, that is 90%, not degrees. My bad. Woo.
Oh.
All right, ladies. You're going to have to share the marker, but come on up and do these. I'm going to grab Mr. Camera that no one knows is here.
Oh, you're home too. Is there another marker? It's more like whiteboard marker. I presume we can share.
So these are the problems. They're going to rotate 90 degrees. They're going to dilate to the right. No, that says reflect to the right. Sorry. They're going to translate down, and they're going to dilate smaller. Okay, go ahead.
Do you want to go first, or?
Each of you do 2 problems. You pick.
Okay, so this one reflects to the right. So let's just say, is that good?
Yes, perfect.
Okay.
Good
now,
job.
Rotation, 90 degrees. So
Oh man, she got the easier ones.
did
I'll help you if you need help.
Thanks.
I guess did I do that wrong?
Let me see. Rotation 90. So it's just a triangle.
Just a triangle.
Good job. Perfect. All right, Marissa, you're up.
Okay. I think I know this one. I didn't mean to make it
Good. You
bigger.
translated it down.
I
Perfect.
think you dilated that one.
Let's not pick on our classmates. All right, now let me see you dilate that triangle smaller.
Does it matter where it goes, what
No.
quadrant it goes into?
You do you, boo-boo.
Okay.
Perfect! Ladies, I'm so proud of you. So just to, you can go sit now.
Okay.
But just to emphasize, to dilate, you make the shape smaller. To translate, so they translated down, they just simply moved it down. To rotate, you get a degree, so that was 90 degrees, and you rotated it 90 degrees. And when you reflect, they reflected to the right, so it just simply flipped over to the right. Good job, guys. I'm so proud of you. Now you can get baked goods. The end. Thanks for coming.